Hi guys, I'm back. Anyway, I'll do another video on this. The wiring underneath is done. Got everything hooked up. Basically all I'm doing now is waiting for my rubber parts to come, especially the ones that's for the tuning capacitor to mount it. I can't get it mounted until I get its rubber supports, which go on here, and then it'll slide in. There's a little spot here, you can see it, but from the top. And there's a little bracket that mounts back here. I've got it put away right now for safekeeping. It just looks like one of the side pieces, except it'll have a hole screw here with a little slot, and it adjusts so you can level and get the tuning capacitor level. So anyway, I gotta wait for those. They should be arriving probably by the end of the week or the beginning of next week at the latest. So when they get in, then I'll get it put on, and at that point then I can put the dial assembly back on, and that leaves just one solder joint that has not been completed, or a couple of them. One is here, and the other is tying into the filament line for the dial light. So anyway, when that gets there, I'll make another video on that. I just wanted to kind of give you an update where I was at. Like I said, everything is hooked up. I got the caps all restuffed and put on. As far as a little tip, and I really on something about when you're restuffing caps, when you take your unstuff from an old cap and you put your new cap in, for one thing you're going to have to wrap it with something. I usually use just electrical tape, but you can use various different tapes or something, just because the new cap is a lot smaller usually than the tube. That gets it to kind of fit tight in there. Then you can either melt the old wax back in if you want. I usually just use black hot glue, or brown hot glue is what I've got, and glue them. Well, the thing is, hot glue is hot and it's flowing, and it takes a little bit of time for it to cool. In the past, I generally took and made use of any chassis holes or anything just to kind of set the cap up straight while that first little, until the glue set up. And I was actually cruising around on on the internet looking for something else, and ran across this idea. So I can't remember who had it. I found it on the Antique Radio forum, but someone, they weren't even talking about it. They were just talking about redoing a particular radio and restuffing the caps on it, and it was just a diary of their progress and what they were doing. But they had made up a little thing like this. I think theirs was actually a triangle. They had a couple of them because they had a lot of paper caps to restuff. But you can take, I don't have an old cap here, but you can take your cap. It's just a piece of cardboard, corrugated cardboard, cut off a box, and either made a triangle or square or something so it'll set up right. Tape it together quickly. And when you glue the one end, glue either end, but when you get one end glued, if you lay it down, it's just going to kind of flow out until it cools. So you can just, the other end, you got the lead in it, sticking out, and you just set it down. The leads will go right in where the corrugations are, and you can just, make these as big as you need for however many caps, but you can do all your caps at one time. Generally, by the time you get done, if you got like 7 or 8 caps, by the time you get to the end of setting the last cap up in here and gluing it, you're ready to probably get the first one out, glue the other end, and flip it over and stick it in there. But it just holds them upright. And I thought it was just kind of a neat little idea, so I thought I'd share it with you. Again, I can't actually take credit for this, and I really apologize. I tried finding the information again where I went, But like I said, it was I don't even remember what radio he was working on, but it was a diary that he was, you know, showing pictures of where his progress and stuff, and just he had his caps he was stuffing, had some of them glued, and they were sitting in these. So anyway, just a little tip. Another thing on this video I want to talk about, and before I get to it, we're going to focus on. I've got the concentric pretty much done. There is a ring that goes around it. I want to paint it. It's got a little rust on it. It's painted black, and I still yet to paint it yet, and I want to go ahead and sand it down, prime it, and paint it. So that's the only reason why it's not on there yet. It just screws in and goes around here. I'll see if I can kind of, whoops, sorry, move this around. I may have to move the move us over here just a little bit. And kind of zone in on this, zoom in, I mean. Anyway, I'm gonna turn. I got my digital meter on this. I'm gonna turn it on to the continuity tester. So when I pull it out, there's continuity. What I'm checking continuity from is the wire that actually goes to the volume control and to the plate. And the biggest thing I went ahead and set the cones to what is shown on the dial, which is for around my area, although some of these radio stations don't even exist anymore. Some of them might have had their call signs changed, and some of them have moved a little bit in frequency. For example, WHO here at the top is at 1000. It's 1040 now, but I set it at 1000 for the time being. But when you're operating this, and it works pretty good, set this over a little bit, so it's actually holding up pretty good. I can really flotate around. If you come to a cone, it goes out. Intermittent, it goes out for you to just do the regular tuning, and you can use the fine like this, or you can use the coarse like this. If you go between cones, it comes back on, so it's shorted. All the way up, it's shorted. If you get it close on the dial, it locks it in. Now this one is working pretty good on all the cones, all the way around. Works good there. Get it lined up on this one. There. Partly, I think one of the big things about this, these cones, if you loosen them, they've got a little bit of play, and they can be tightened down a little closer this way or a little bit further away. It's not much, but it's enough that can throw off that switch down below the lever. So if you're having troubles with it, you might just try to adjust and move them over. Now I made a tool for it. I got somewhere around here. I just took an old screwdriver. This one happened to be a Phillips, and I took my Dremel grinder, Dremel, and cut it down some. But then I still left some of the Phillips still on there, and then just started coring down through the center so it fit over the cone. And once I got it down where it fit, the two pieces left over of the Phillips end would fit into the pins all the way to the bottom. Then I kind of tapped them over. They had to be bent over just a little bit to really engage good. But it works nice and stuff, so it goes in there really nice and fits good. The thing I've found, if you adjust these with the thing all the way down over the cone, as your arm drove all the way down, and then you adjust them to where you want to. For one thing, you can get them right on where your dial says it's supposed to be, or wherever you want to set them. But it also centers them, I think, pretty darn good, so that they fit where they're supposed to, so that the switch works properly. Now, this switch only has 3 positions: all the way out, intermittent, and then all the way in. Now, it will make contact all the way in if it's not on a cone. All the way out, but intermittent, it doesn't. So intermittent is to dial without using the cones. And again, you can use the coarse, and then you can use the fine. The knob had lost its rubber. I think I said this previously, and I had a rubber O-ring I glued on there. So it works really, really good. Catches good, so for fine tuning. Anyway, I wanted to show that. So if you're having problems centering them, try making a tool and then doing it through the hole here with it pushed all the way down over the cone. You basically loosen the cone up, and then you push the knob all the way down over the cone, engaging the cone, loosen it up, and then you can just move it with this, okay, until you get to your wherever you want to set it at, and then lock it down, and that will center it properly so it's not too far out or too far in and catch. Because I've had these at least in a couple spots where if they're loose and adjusted without using this in too far, they'll actually hit that mechanism, that lever, a little bit. It'll drag against them. If they're too far out, especially up towards the outer edges, way up in here, it seems not want to work quite right. The biggest thing is it's not losing contact. By lubing it up good and getting it nice and clean, so it works like it should. Okay, so anyway, that's that. Now let's talk about what the other thing I want to talk about. Let me move you back over here, mainly because this makes a nice little table. And first I'll zoom out a little bit. Okay, so canned ohm resistor. How did I determine the resistance in these? And I've talked about this before, but I thought maybe I may go over it again for anybody that's new to my channel. Plus, I see it still being something even fairly recently on the forums, trying to determine wattage. So I want to talk about how I came up with the wattage on that. Don't mind the pink. That's just me keeping track and make sure I are not looking at where I already connected wires. So let me zoom in just a little bit on the schematic. If it's a little small, I apologize for that. Now each radio is going to be a little bit different, and how much information you have available to you is going to be a little different. In this particular one, and we'll go over this particular one, and then I'll explain a little bit what you could do if you don't have as much information or something. On this radio, one nice thing a little bit about it is they give a nice little voltage table here, and it's probably kind of small for you to see, but it's right here. It shows all the different tubes from the underside, and the voltages on the plates, screens, and heaters, and so forth. So using that information, I found that the voltage at this point right here on the rectifier, let me move this up a little bit, was 315 volts. And I found out over here it's 250. The way I came about that is if you follow this line up, it goes up here and goes directly to the screen pin 4 of the 6F6 output tube. So I looked at the screen voltage, it was 250 volts. So there's nothing in that line that drops that voltage. So I got 315 and 250 here. Well, and it gives me the ohm DC ohm value of the coil, field winding coil here. So all I had to do is subtract this voltage from this. I think that gave me like 65 volts that's dropping across this coil. I took that voltage, Ohm's law, took that voltage divided by this resistance, and it gave me 57 milliamps. That goes through that coil. But that's not the end of the story. Not all the current for this radio goes through that. If you notice back here, we have a voltage divider here. Now the one thing I did not figure in here is a little bit of current that goes through the voltage divider accurately. You can do that because it should be 315 here. The other voltages just tap off. And you come down here, you're back to ground. So you could actually work that out. I just took a ballpark figure on it. So anyway, you come back here, you look up, you see this voltage divider, but there's several. It's supplying, well, it supplies basically between here and here, it supplies the entire 6/8 A8 first detector oscillator mixer tube up here. So I looked up in the tube manual, found the voltages that were close to what the voltages on this voltage chart is in the tube manual. I actually used higher because this tube runs at 180 plate. I used the 250 out of the chart. I used those currents for everything in here that needed to be wrote down. You have the plate current, you have the screen grid current, you have this anode grid here, which is part of the oscillator. That makes up the plate for the oscillator. You have its current. So it worked out 3.5 milliamps for the plate, 2.7 for the screen milliamps, and 4 milliamps for the grid here that acts as the plate, or it's the anode for the oscillator section. I took those and added those together. The other voltage that's taken off here comes up and supplies the screen for the 6K7. Its plate is supplied by this side over here. I just need the screen. That came out to 1.7 milliamps. I added those together along with this and add a little bit of drop across this voltage divider and came out with around 68, well 70, and I ended up rounding that up to about 80 milliamps. Basically having about a 10 milliamp drop across here. If there was no loads, no nothing, just the dropping, just the voltage divider in circuit. That works out just roughly about 1 watt on the 202, which I use a 200 ohm. Now, why did I use that current is because, like I said before, on any circuit it's closed. So whatever current flows out of this power supply, coming out this way, going up this way, all through this radio, must return back to the power supply. The return is the center tap. Well, it comes down here and it goes through this. So the return is right here coming through here. So all the currents coming out of here has to come back in here. All you got to do is figure up these currents, use those. It's I squared R. I use a 200 ohm resistor. It works out about 0.98, 1 watt or so, a little over 1 watt actually. And I doubled that, or got as close to double that, which is a 2 watt, and that's what I put in. The 10 ohm that I put in place of the 8 ohm, it worked out about 50 milliwatts or so, and so I used a half watt. That's well above that wattage. And then the 33 ohm I put in here, I used a half watt on it. It came out about 160, 170 milliwatts. Well, that's more than double, so it's perfectly safe. But that's how I came up to the wattage. Simply just take all your currents that you got through the radio. Now, some radios you're not going to have much for the voltages. Some you may not have any information on, like if it has a fill coil, what the actual resistance reading is on it. I mean, you can take your own and just use that if you want. But some radios are pretty limited in the information they give you. In a case like that, just look all the tubes up, use the next highest voltage that those tubes are normally operating at that you can find in the tube manual. Your tube manual will generally give they'll give maximum, and then they'll give two basic operating condition scenarios. So like on the 6A8, if we look at this, we have the maximum here, but down here we have two typical readings. So, and that's going to be the same way throughout the tube manual on all different tubes. So if your radio, generally they'll give you at least plate voltages. So if you start looking up all your tubes and comparing that plate voltage, if it say is 180 volts, well, it's definitely much higher than 100. Use the 250. It's going to have a little more current, because if you notice the difference between these two currents opposed to the voltages. But that's okay if it has a little higher current. You're going to use that current to figure your wattage. Well, and then you're going to double that wattage. So that means your wattages are going to be a little bit higher than what really is needed in there. There's nothing wrong with that. It's okay to go a little higher wattage. So all you got to do is look all your tubes up, make sure you know, if they're pentodes or something of that nature as opposed to triodes, you got to remember, you also got to look up the screen currents. Your mixer tube up front, your converter tube, there'll be three currents there that you have to look up and add together. Just to add all these currents together, and that's the amount of current that's being drawn on the radio within a ballpark. And then you can figure out, that'll be the return current back through any of these resistors here if it has this, that you can then use I squared R. Take the current times itself times the resistance, and then double, or as close as possible, double that wattage. This works out to be just a little over 1 watt. The closest thing I had was 2 watts to double. It's like 1.1 or something in actuality, but it's probably closer to this 0.98 because I'm using much higher voltages than I needed here. So the currents are going to be definitely lower, but that's okay. There's nothing wrong with that. So I use 2 watt here, half watts on the other two. So I think that's about all I got for you. When the parts come in, we'll go through getting this thing the rest of the way together. I've got this pretty well cleaned up and everything, so, and lubed up, so it works really nice. And we'll when I get the rubber pieces, we'll put it on and get it hooked up and get the concentric dial put back on, and see how well she works. You know, probably have to end up doing alignment most likely, or may not. It's hard telling because I haven't touched anything, and as long as it was pretty close to start with, then it'll probably be fine, but we'll double check it. So anyway, guys, I guess that's about all I've got for you for today. One other little thing is, like I said, this is the last little piece that goes on the cone. There's a piece of felt that goes underneath here. That's what these fingers are for. What you see here, they hold that felt on. I got it off. But this has got little blemishes in it. It may not show up in the video, but there's a little rust on it, so I'm going to sand this thing down and get it cleaned up and repainted. I just haven't got around to it yet. We come over here to the mechanism, and it just basically goes around this. You have to take the knobs back off, and there's 2 screws underneath where the knobs are. Screws in here and holds that on. So I'll get to work on that too while I'm waiting for the other parts. The speaker wire was pretty crunchy, so I went ahead and replaced it. And I did replace a couple wires in here in the radio because they were kind of crunchy. Of course, the power supply or the power transformer wires, all of them, I went ahead and replaced. And a lot of the rest of them seem to be okay. So I left them. I mean, they're a little stiff, but they're not real bad. So unless they start causing trouble down the road, I'm not going to be too concerned about them. I mean, I was able to twist this original wiring. I was able to retwist it back up the way it was, and it didn't break any. The insulation withstood it without any problems. So some was crunchy and some wasn't. So the ones that were, I replaced. Like I said, the speaker wiring was kind of getting pretty bad. It was breaking. So anyway, if you like the video, give it a thumbs up. And if you're new to my channel and you like seeing about old radios and TVs and learning a little bit about theory, please subscribe. And so I want to thank you for all your comments, guys. Appreciate them. I'll try to get to, well, basically most of them is just a thanks. So thanks again for your comments and your kind words, and so I guess that's about all I got. So I guess I'll see you on the next video, guys. Thanks again for watching.